we are starting a new chapter, and the first assignment doesn't really fit with the rest of the chapter, but we have to put it somewhere, so we've decided to stick it into this chapter. And we're going to be solving radicals. Radicals are things like square roots, third roots, and the like. So if I had something simple, such as the square root, oh my goodness, the square root of x equals 3, what number makes that true? 9. The square root of 9 is 3. What if I had the square root of x minus 1 is 7? That's a little bit harder. Not 48. You're close. 50. So what number can I subtract 1 from and then take the square root and get 7? So it would be 50. But these are going to get even more complicated, so solving them in your head is not always going to work. So we need a way algebraically to solve this. And when we solve algebraic equations like this, then we just do the opposite of minus 1, which is plus 1. And then we do the opposite of multiply by 4, which is divide by 4, and I get x equals 1. What does that represent? What does 1 mean in this situation? It's the only x that you can plug in and get 3. So if I take this 1 and I stick it in here, 4 times 1 is 4, and 4 minus 1 is 3, and it turns out that is the only place where that's true. You plug in any other number and you will not get 3. So we're going to use the same basic idea here, but what is the opposite of a square root? So if I did the square root of 16 is 4, it's an exponent like that. So the opposite of a square root is a squared, which is why we call it a square root, because the opposite is a squared. Are they out of Chromebooks? Hang on a second. So if you have the square root of x, the opposite of the square root is squared. So I need to square both sides. And there's actually a 2 here. We just don't write it because we're lazy. But that cancels that, and I'm left with x equals 9. Okay? Down here we do the same thing. We square, and this cancels that, and I get x minus 1 equals 49. And then using the rules of algebra, we add 1, and we get x equals 50. Okay, what does 50 mean? It's the only number you can plug in, and you get the answer on the other side. So if I put 50 in there, 50 minus 1 is 49. The square root of 49 is 7, and it works. Okay? Okay, what about this? That. Square both sides, and the square root and the squared cancel. 2x plus 4 equals 36. Now what? Subtract 4. 2x equals 32. Divide by 2. And I get x equals 16. Okay, and let's just plug it in and see if that works. 2 times 16 is 32. 32 plus 4 is 36. Square root of 36 is 6. Okay. However, watch this. Square both sides. On the left side, I'm left with x minus 5. But on the right side, I get 9. What is negative 3 times negative 3? Positive 9. Add 5. And I get x equals 14. Okay, I want to, let me get rid of this stuff. Watch what happens when I plug in 14. So I'm going to put 14 right there. The square root of 14 minus 5 is the square root of 9, and that equals 3. What do you notice? It's not the same. So 14 did not work. Why not? And this is kind of tricky, but look at that original statement. The square root of x minus 5 is negative 3. That can't happen, right? What happens when you take the square root of a positive number? What sort of answer do you get? A positive. The square root of 9 is 3. The square root of 100 is 10. If the number inside the square root is positive, then your answer will be positive. What if the number inside the square root is 0? What is the square root of 0? No. What times itself is 0? 0. Right? So the square root of 0 is 0. What about negatives? What happens when you square root a negative? You get an I. So what is the square root of negative 9? You can't do that. You can do it with i's. Not irrational, imaginary. So what number times itself is negative 9? There isn't a real number, right? 3 times 3 is 9. Negative 3 times negative 3 is also 9. And 3 times negative 3 is negative 9, but it's not the same number. So this does not have an answer on the real number line. Now we've invented a new sort of number called imaginary or complex numbers, but that doesn't apply right here. So look at this original statement. What number can you take the square root of and get a negative? You can't. There is no number that you can take the square root of and get a negative number. The number has to be positive, 0, or imaginary, but we're not going to worry about imaginary. Okay? So, right there, I should be able to look at that statement and say, no solution. There is no way to answer that question. Okay? And it's not undefined. It just doesn't exist. There is no answer. Okay? It's kind of like saying x plus 1 equals x plus 2. What number makes that true? There isn't one. If you have a number and you add 1, and you take the same number and you add 2, those two values will never equal. So there's no solution. So when you're looking at these, if you notice that the answer is negative, then automatically you should think no solution. Okay. So what about this one? Does that one have a solution? It equals a negative. So what do I need to do to figure out if this has a solution or not? I need to move this. Ooh, didn't mean to do that. And I get the square root of x minus 4 equals 2. Does that have a solution? Yes, let's figure out what it is. Square both sides. X minus 4 equals 4. and x equals 8. Does everybody understand that? Okay, let's do another one. Does that have a solution? No. I need to get the square root by itself. So I subtract 5. And I get the square root of 3x is equal to negative 1. And the square root cannot equal a negative number. So that is a no. Even though in the beginning it looked like we had a solution because the 4 was positive. But when we move that 5 to the other side, you'll notice that that doesn't actually work. Okay. Let's look at your assignment. We're not going to do it all today. So this one's easy. The square root of what number is 8? That's just 64. Okay, this one we square both sides. So we square this side and square this side. And we get w minus 9 is equal to 36. And then we add 9. W equals 45. Okay. Is this one going to have a solution? Yes. What's my first step? Add 1, and I get the square root of 4v minus 16 equals 1. So, equals 2. So 2 equals the square root of 4v minus 16. Square both sides. 4 equals 4v minus 16. Add 16. 20 equals 4v. Divide by 4, and v equals 5. Now, what if I solve this and I get v equals negative 5? Is that okay? Yeah. V can be anything. But, going back to the original, this square root here has to equal a positive number or 0. It cannot equal a negative number. Okay. This one looks a little bit more complicated, but it turns out it's easier. I have square roots on both sides. What should I do? Just square both of them. And I get 2x minus 1 equals 5x minus 10. Now what should I do? Subtract 2x. Add the 10. So 11 equals, and divide by 3. X is 3. Do I have to worry about no solution here? Can a positive square root equal a positive square root? Yes. So we don't have to worry about no solutions on this type. Okay. So number 5 and number 6 you don't know how to do yet. So today I want you to do 1 through 4, skip 5 and 6, and then do 7 through 10 and skip 11 and 12, and then do that to the end. And next time we meet, I'll teach you how to do the harder problems. So we'll break 4-1 into 2 separate days. All right? Okay, get to work.